Welcome to Microbe Mania. Hey, microbe explorers. If you're ready to dive into the fascinating world of microbes, you found the right place. Microbe Mania is your go-to channel for all tiny but mighty, from bacteria and fungi to viruses and beyond. Get ready for mind-blowing facts, super cool experiments, and everything you need to know about the microscopic world. So grab your magnifying glasses and let's get into the mania of microbes. Like what you see, hit subscribe and join the microbial revolution. Everyone, welcome back to my channel. Don't forget to click subscribe if you want more daily updates on Microbe Mania, where we are going to study about interview questions and answers of microbiology and pharmaceutical industry. Good day, class. Today, we're going to talk about an important aspect of water analysis, filtration. Specifically, we'll be discussing why a 0.45 micron filter is typically used for analyzing water, and why 0.2 micron filters are not always the best choice for this purpose. Let's break it down step by step. When we talk about filtration in water analysis, we're essentially trying to remove particles from the water that could interfere with our results. A 0.45 micron filter is commonly used for water analysis because it effectively balances removing particulate matter while preserving the integrity of the sample for accurate chemical analysis. Here's a detailed explanation of why a 0.45 micron filter is preferred over a 0.2 micron filter in many situations. First point is filtration efficiency for particulates. 0.45 micron filter. The 0.45 micron filter is designed to remove particles such as suspended solids, larger microorganisms, like some bacteria and algae, and other visible contaminants in the water. This size is effective for filtering out debris and particles that could interfere with chemical analyses without overfiltering the water. For 0.2 micron filter, a 0.2 micron filter removes even smaller particles, including bacteria that are smaller than 0.45 microns. While this is excellent for microbiological testing, like removing pathogens, it's not always necessary for chemical analysis, as it may remove particles that don't impact the specific analysis being conducted. Second, preserving sample integrity. 0.45 micron filter. Using a 0.45 micron filter allows dissolved substances, like ions and smaller organic compounds, to pass through without being adsorbed onto the filter. This preserves the chemical composition of the sample, which is important for accurate measurements of dissolved elements such as nutrients, nitrogen, phosphorus, heavy metals, and other water quality indicators. For 0.2 micron filter, a 0.2 micron filter has more surface area and a finer structure, meaning it can adsorb more substances, especially organic compounds, which may alter the sample and affect the results. For instance, some dissolved organic materials may cling to the surface of the filter, leading to inaccurate readings for certain chemical tests. Third, clogging and filtration practicality. 0.45 micron filter. The 0.45 micron filter is less prone to clogging, especially in water that contains a higher concentration of suspended solids. This makes it a practical choice for filtering larger volumes of water, without frequent replacement or maintenance of the filter. Now, 0.2 micron filter. The 0.2 micron filter has smaller pores, which can easily clog when filtering water with particulate matter or suspended solids. This makes it less efficient for large volumes of water or when dealing with water that has high turbidity, cloudiness. Fourth, standardization in analytical methods. 4. 0.45 micron filter. In many environmental and water quality testing protocols, like those set by organizations such as the EPA or STM, 0.45 micron filters are a standard because they strike a balance between removing unwanted particles while still allowing the sample to accurately represent its dissolved chemical content. This consistency is important for comparing results across studies or laboratories. Standardization in analytical methods. 0.2 micron filter. The 0.2 micron filter is used in more specific applications, such as microbiological testing, where removing bacteria and viruses is crucial. However, using this finer filter for general chemical analysis can interfere with the sample, potentially making it unsuitable for certain measurements. Fifth point is cost and efficiency. 0.45 micron filter. Filters with a pore size of 0.45 microns are typically more cost-effective and durable for routine water testing, especially in large-scale analyses. They are widely available and offer a practical solution for ensuring the sample is free of larger particles without compromising the chemical analysis. 0 to micron filter. These filters tend to be more expensive and may need more frequent replacement or cleaning, especially in waters with higher levels of particulate matter. The added cost may not be justified if the goal of the analysis is not microbiological in nature. Conclusion: a 0-5 micron filter is used for water analysis because it provides an effective compromise between removing unwanted particles, such as larger microorganisms and suspended solids, while allowing the water's dissolved chemical composition to remain intact. It is the standard in most environmental water quality testing because it preserves sample integrity, prevents clogging, and is more cost-effective than the finer 0 to micron filter. A 0 to micron filter, while essential for certain applications like microbiological testing, is not necessary for many chemical analyses and can lead to sample loss or contamination of dissolved substances. If you enjoy the content I'm creating, please consider subscribing to my channel to stay updated on new videos and content. Thank you.